Hey class, this is a solution for problem number 5. In this case, we're trying to figure out the slope of a line such that if it's tangent to the curve at one point. So I noted up there that the y-intercept of that line has to be 0, -2, and we're just trying to make the line and the curve cross in one spot. You need to find that ordered pair that makes both equations true at the same time. And I think the way to do that is to set those two expressions equal to one another. At that point of intersection, you will wind up having the same y value, so then I think it's important to note that we've got this equation here such that the line expression is equal to the curve expression. So do that. So then just a little bit of algebra moving forward. I think the one tricky step is realizing that you've got minus mx and then a minus 4x. So I'm going to factor -1 out of those two expressions. And then we'll also factor x out of those two expressions. And I just put them on either side of the set of parentheses there. Let's undo that process. And then finally here we've got this notion that we've got this equation, and it has the letters m and the letter x, but then the letter m is the slope of that tangent line up there. And then the letter x is any value of x that we plug into this tangent line and then also plug into this curve. And what we are trying to do is when we set them equal to one another and we say let's find the value of x that makes that true, we're trying to figure out where those curve and that line touch. So I think that's an important idea. So we want one point of intersection. That means that if I look at this quadratic equation, there's going to be one value of x that makes this true, which means that the discriminant of this quadratic equation has to be 0. So the discriminant is going to be the value of b squared, the linear coefficient squared, minus 4 times the quadratic coefficient multiplied by the constant term. So I've got that expression written over here, and we can expand that expression. There's a couple of steps in between there, but I trust that you can take care of that. And then that equation is true if m is 0 or m is -8. A little bit of cancellation and some factoring should take care of that, along with one step with the zero product property. So what that basically means is we've got actually two possible lines that could be tangent to the quadratic curve, x squared minus 4x plus 2. And then those lines also go through the y-intercept of 0, -2. Those two lines are y equals 0, x minus 2, and then also y equals -8, x minus 2. I hope that helps. I'll see you on Monday.